All right, well, let's talk a little bit about solving these kind of problems right here. And when we talk about the rate of which a graph changes, if it is proportional to itself, really we're always going to get this model right here, y equals c times e to the k times t. And so most of the time our model then is going to be based on, well, what initial values do we have and how do we fit that. So let's start with the assumption that we're given this curve y equals c e to the kt, and specifically in this case, what's going to happen is that when x is equal to 0, y is equal to 4, and when x is equal to 5, y is equal to 1 half. So what will that mean for us? Well, okay, let's go ahead and put this into perspective. What that means for us is that we're going to say we will have 4 equal to some constant c times e to the k times 0. And we know that anytime we put in 0 for that e, right, e to the 0, that's going to be 1, so 4 is equal to our constant c. And that's always sort of the easy part. If we have that 0 point, we can solve for c pretty easily. All right, so now we've got this model. Y is equal to 4 times e to the k times t. Right? It's t, not x right here, so we do want to make sure that we're careful right there. Okay, well, how about this other point? What does this guy mean? Well, in this case, if x is 5 when y is equal to 1 half, that means we have the following. 1 half will be equal to 4 times e to the k times 5. All right, so this time I'm going to solve for my constant k algebraically. I want an exact value. So if I were to do that, that would mean that I would have to divide both sides by 4, or really multiply by 1/4, a little bit better. So I'm going to get 1/8 is equal to e to the 5 times k. Just write it that way so it's a little bit easier for me to follow. And of course, to get that constant by itself, we need to get 5k by itself, which means we have to take the natural log of 1/8. And that'll be equal to 5 times k. So solving for k means that we're going to divide both sides by 5. So I get something that looks kind of like this: 1/5 of the natural log of 1/8. Right? Now, if you remember your properties of logarithms, another way of writing the natural log of 1/8 is like saying the natural log of 1 minus the natural log of 8. And of course, the natural log of 1 is 0. So k could also be expressed as negative 1/5 times the natural log of 8. And this is more likely the way that you would see it if you were ever to see this written. Kind of like I'm going to write it right now. That's right. Y is equal to 4 times e to the negative 1/5 of the natural log of 8 as our constant times t. So if we were to solve for values of x, right, we should be able to find exactly what's going to happen right here, right? We start putting in values of t, and solving for that, we're going to get our values of y. All right, so there we go. Good luck.